This covers Chapter 9, which deals with rational functions, and Chapter 10, which deals with function operations and compositions of functions. And I've got open up here the Unit 6 review handout, which looks like that. And I also have the Blackline Masters. Well, they're called Blackline Masters. It's this handout that I've given you as well. I also have the Unit 6 note package open if there's anything that you need me to help you with that. So all that being said, does anybody have any questions from any of the review materials that I've given you so far? 10? Certainly. Number 10 is, well, I was going to say number 10 is an important question, but any question that I give you on the review is important, otherwise I wouldn't give it to you as part of the review. So you're given a rational function, and as we've said a number of times, it's all well and good to talk about rational functions or questions or functions in general that have numbers with them, right? But when it comes to exam questions, sometimes those numbers are hidden from your view. We don't know what b is equal to, but we do know that the function is f of x equals b times x, subtract b squared over x squared minus b squared. And this question is all about non-permissible values, specifically the difference between a vertical asymptote and a point of discontinuity, or a hole if you like. But when you analyze a rational function, everybody, you have to factor everything completely to decide, well, to decide, one, what are the non-permissible values of x? Two, which of those non-permissible values, if any, are vertical asymptotes, and which, if any, correspond to holes. So when I factor this completely, I have f of x is equal to, I can factor a b out of the numerator and be left with x minus b. Over the denominator, which is a difference of squares, I can factor into x plus b, x minus b. And what that's telling us, everybody, is that there's two non-permissible values. And I think many people would have known that x is not allowed to be plus or minus b simply by looking at this denominator. So bottom line is we have x is not allowed to be b, and x is not allowed to be negative b. Now, because the b non-permissible value, because this non-permissible value comes from this factor, which cancels with an identical factor on the top, and I'm not going to cancel them, we can see they cancel. That means that there's a hole at that non-permissible value. So there's a hole here, or a point of discontinuity at b comma something. On the other hand, this non-permissible value comes from this factor in the denominator, and that factor does not cancel, so the rule we've learned is that that means we have a vertical asymptote at x equals negative b. All right. Now, that's not really the question. The question is about what the function is approaching, and I'm going to get to that in a second. But let's find out the y-coordinate of the hole. And I'm finding out the y-coordinate of the hole with you here because we need that to answer the question. However, there might be a question on an exam that just says, what is the y-coordinate of the hole? Or what is the range of the graph, in which case we would have to say y is not equal to the y-coordinate of the hole. So we have to know how to find the y-coordinate of the hole. To determine the y-coordinate of the hole, we take the function and we reduce it down by canceling those factors. Now, just a second though. That's not the function. I'm getting a little bit off track of this question. But if you are going to write that this is a function, you still need to say that x is not equal to b even though the x minus b is gone. You don't absolutely need to say that x is not equal to negative b, but why not? So this is the function. And you don't have to say x is not equal to negative b because the x plus b is still there. Okay. To find the y-coordinate, what we do, the y-coordinate of the whole, is we put in the x-coordinate of the whole into whatever is left after we reduce the function down. So the y-coordinate of the whole will be, well, I want to be very careful here. Maybe I'm being overly picky. F of b doesn't exist, right? Because b is not permissible. But that means when we calculate what f of b is, it's going to be the y-coordinate of that opening, that hole. So we put in b for x, and we end up with b over 2b, which is 1/2. So I can go over here now and I can put 1/2. Now here is the most important part of this question. Everything we've done so far you need to know how to do. But when we have a graph, and there's a vertical asymptote, but there's also a hole someplace. I'm not worried about what this graph looks like. I'm just talking about vertical asymptotes and holes in general. Let's say there's a vertical asymptote on a graph. The fact of the matter is the graph looks like this around the asymptote. I mean, maybe both pieces are pointing down, maybe both pieces are pointing up, maybe the left is up and the right is down, it doesn't matter. But the idea is, with this, I'm going to put a letter here. I'm just going to say it's x equals p. The idea is, as x approaches p, y gets infinite. Okay. This was in one of the first lessons that we did. However, when you take a look at this hole, and I'm just going to say it's at q, comma, r, I don't want to do that. It looks like an asymptote. That point has coordinates of q, comma, r. I'm just making up some numbers here. But what's happening here is as x approaches q, y approaches r. This is the big picture in this question. This is what this question is about. As x approaches the non-permissible value that's a vertical asymptote, the function approaches infinity, or negative infinity. As x approaches the non-permissible value where there's a hole, y approaches the y-coordinate of the hole. Right? The function, this is maybe what the function looks like. So as x is getting closer and closer to that x-coordinate of q, y is zooming in on that y-coordinate of r. So now we can answer the question. As x approaches the non-permissible value that corresponds to the vertical asymptote, well, it's got to be a or b. This is the behavior of functions close to vertical asymptotes. As x approaches the non-permissible value that corresponds to a hole in the function, what does y approach? Well, y will approach the y-coordinate of the hole, which is 1/2. So the correct answer is B. And this is for students, I understand this is a weird question, because without doing the work, you look at it and you say, well, why would it be 1/2? Where does the 1/2 come from? And the answer is, well, you have to reduce the thing down and put in the non-permissible value of the whole. By the way, so are you okay with that explanation? Good. By the way, I can easily come up with another, it just occurred to me, another really, really good question surrounding this function. I could say, so an alternate question, what's the range? What's the range of y equals bx minus b squared over x squared minus b squared. Well, the degree on the top is smaller than the degree on the bottom, which means there's a horizontal asymptote at y equals 0, which means y is not allowed to be 0. But because there's a hole, and the y-coordinate of the hole is 1/2, y is also not allowed to be 1/2. So I could design a numerical response question and say, the range of this function is y is not allowed to be, I want to stay away from a's and b's here, d or e over f. What are the values of d, e, and f? Well, d is 0, e is 1, f is 2. And there's all kinds of scenarios I can come up with where I give you a function like this with a's or b's or other parameters in it that you don't know, but you still analyze it the same way. Factor and look at the factors. Other questions? Yeah. 11? Speaking of which, here's another example like that, right? So what have we got going on here? We have a rational function, and you're asked about vertical asymptotes and points of discontinuity. So what do? You factor. You have to factor to do this question. And this question is really very similar in terms of the work we have to do here, Maria. Very similar to number 10. So how do we factor this expression? Well, let me write this out first. I want to ask you a question here just to make sure, because I think I need to fix something. Does your thing just say a rational function is described by and there's no y equals? That's what it looks like? Okay. I really should have an f of x or y there. But anyway, I'll put it in here. 2px squared minus px over 10x squared minus 3x minus 1. So we have to factor everything completely. In the numerator, it's a binomial, but there's a common factor of px. And I'm left with x minus 1. In the denominator, it's what I've always referred to as a complex quadratic. Thank you. Thank you, Paige. 2x minus 1. I've always referred to the denominator as the type of thing which I call a complex quadratic. I call it a complex quadratic because the leading coefficient is not 1, so it requires a little bit more thought to come up with the factors. I would guess 2x and 5x given that I see a 2x minus 1 on the top. And you know, I would probably guess this before I even FOIL it out, because there's a 2x minus 1 on the top, so I'm thinking, well, maybe that's going to be where a hole is. And we can FOIL this out. When I do, I get 5x for my outer product and 2x for my inner. And if the 5x is negative, which it is, it gives me the negative 3x. So it's factored completely. So what does that tell us? It tells us that there is a hole and I know point of discontinuity sounds more sophisticated, but we can call it a hole. And that's sometimes what it's called on an exam. A hole at 1/2, and Maria, you see where I'm getting the 1/2 from? Okay. Comma, whatever we get when we put 1/2 in, if you don't follow this finding the y-coordinate of the whole thing, you're going to get burned about 3 times on tomorrow's exam. And you'll get burned on the diploma exam almost guaranteed in one of the questions. So I'm just going to go ahead and write the function in a different form. I'm going to write px over 5x plus 1. And I am going to say that x is not allowed to be 1/2. And x is also not allowed to be negative 1/5. And Maria, do you see where I'm getting the negative 1/5 from? Okay. That's where the vertical asymptote is, by the way. So right away, we see that it is either A or C. Okay. So how do I find the y-coordinate of the hole? The y-coordinate of the hole, bless you, is found by taking the x-coordinate of the hole and putting it into the function. We're not allowed to do that, but again, we're putting in a value of x that doesn't exist, so what we're getting is a value of y that doesn't exist. It was 1/2. We've got to be careful here with some fractions. We have p times 1/2 over 5 times 1/2 plus 1. So clearly we're going to get a p. What is this? This is 1/2 over 7/2. The bottom is 5 times 1/2 is 5/2 plus 1 is 7/2. This is times p. I can multiply the top and the bottom by 2, and I can see you've stopped writing. So you get it now, right? You're getting the answer. So what happens then, and I don't like working left to right, but in this case, I'm going to anyway. I'm getting a p on the top and a 7 on the bottom, which tells me that the whole is at p over 7 for y. Okay, so the whole is at 1/2 comma p over 7, which is A, and the asymptote, the vertical asymptote, is at negative 1 over 5. You know, when I say you're going to get burned 2 or 3 times if you don't understand this y-coordinate thing, it may not be one of these complicated questions with A's and B's and P's and Q's and all that other stuff. Could be just find the y-coordinate of the whole. I did want to make a note here with regards to number 10 and 11 is what has not been asked in either 10 or 11, which didn't occur to me until just now, is I could ask you for the x-intercepts or the y-intercept. Right, the y-intercept would be found by replacing x with 0 and getting in this question, number 10, the y-intercept is equal to b times 0 minus b squared over 0 squared minus b squared. You're going to get negative b squared over negative b squared. You're going to get a y-intercept of 1. Okay. X-intercepts are wherever y is equal to 0. But the kind of shortcut that I've taught you here is when you look at things in factored form, the x-intercept will be the 0 of a factor that's in the numerator but not the denominator. And there is no factor in the numerator that's not in the denominator. These cancel. So that 0 of b gives a whole. There's nothing else left in the numerator. There's no x-intercepts of this function. There's no x in this. This is just a number. There's no x there. If I take a look at this one and I say, well, what are the x-intercepts? Just looking here, everybody. Just looking here. There's a vertical asymptote at negative 1/2, at negative 1/5 for x. There's a hole at positive 1/2, and there's an x-intercept at 0. The y-intercept, we can go ahead and put 0 in for x. If you put 0 in for x, I'm not going to worry about these. You're going to get 0 over something. The y-intercept is 0. Goes through the origin. The other thing that wasn't asked in question 10 or 11 is, where's the horizontal asymptote? The horizontal asymptote for number 10 is y equals 0 because the degree on the top is smaller than the degree on the bottom. The y-intercept for number 11 is 1/5, because the degree on the top, the highest degree on the top is the same as the highest degree on the bottom, so you take the coefficients and divide them. You take 2 divided by 10, so you get y equals 1/5. Between these two questions, there's a whole plethora of things I could ask you. I could ask you about the intercepts, horizontal asymptotes, y-intercept, x-intercepts, vertical asymptote, coordinates of the whole, lots of stuff. Okay. Other questions? Yep, Markman. 35? You shouldn't be surprised on the exam tomorrow, and certainly not on the diploma exam, if you see compositions or operations on functions that tie into logarithms or exponents, or in this case, trigonometry. So r of theta is equal to f times g of theta. What is the value of r plus h of theta? So we want to start off with, what is r of theta? R of theta is equal to f of theta multiplied by g of theta. Well, f of theta is 1 minus sine squared of theta. G of theta is tan squared of theta. Well, I'll just throw it out here. How many of you see, and I know it's been a while, and we will do lots of review with trig before we get to the diploma, but how many of you see that this is equal, in fact, to sine squared of theta? The reason is, and I'm not even close to getting the answer to the question yet, I'm just simplifying the first part. You should recognize this as cos squared of theta using the Pythagorean identity. You should know, and I think I've done a fairly decent job of reinforcing this, that if you want to simplify trig expressions, your first line of attack is almost always to think sines and cosines. And tangent of theta is sine of theta over cos of theta, so tan squared is sine squared theta over cos squared theta. So an interesting thing happens here. R of theta is just sine squared theta. Let me repeat that. R of theta is sine squared theta. And I know that there will be people in the room who will want to build the whole function r plus h of theta first and then simplify it. I'm not recommending that. Anytime you see something that can be simplified, even though you're still 1 or 2 steps from the answer, it should be simplified. So now, what is r plus h of theta? Well, that's r of theta plus h of theta. R of theta we've seen as sine squared of theta. I'm guessing h of theta is cos squared of theta. Nope. Oh, interesting. Nice. 1 over 1 plus tan squared of theta. Now, one of the things I didn't say, everybody, and I can point it out now, is this is a numerical response question. We want to get a number out of this. And that's why I said, I bet you h of theta is cos squared theta, because sine squared plus cos squared gives you a number. Well, h of theta is cos squared theta, but you need to use an identity to demonstrate that. So if you look at your formula sheet, Markman, 1 plus tan squared theta is secant squared theta, I believe. I know we haven't been using our formula sheet, so looking around, nobody has it out, but is that correct? 1 plus tan squared is secant squared. All right? So this becomes sine squared theta plus 1 over secant squared theta. So that's sine squared theta plus cos squared theta, which is 1. A few years ago, I could have probably predicted I shouldn't say it that way. A few years ago, if you said, what kinds of written response questions might there be on a diploma exam, my pool would have been very small. I would have had a very small pool of items that I could guess at. And now I've come to learn that they will give you just about anything. This could have been a written response question. Given all of this, find the value of r plus h of theta. 2 marks. So it's kind of like a proof in a way. It's not really a proof. Does that help though? Okay. So the answer would be 1.0 because it says to the nearest tenth. Other questions? Go ahead. 19. I'm sorry, you're going to have to repeat that. 19? 19? A lot of questions today about points of discontinuity, which is good. And it is a slippery kind of thing. Okay? This one, though, and Brendan, was this one of the questions that you had asked me about? This is a brutal question. It's really a killer kind of question. And the reason for that, I think, is that as soon as you think you've got your head wrapped around this, there's an added wrinkle. There it is. So this is about equation building that we've talked about in class. So the domain of a function is, and it's a rational function. The domain of the rational function is x is not allowed to be 2 or 5, otherwise it's a real number. Well, that means that there must be an x minus 2 in the denominator and an x minus 5 in the denominator. So we've checked that box, so to speak. There is a horizontal asymptote at y equals 0. All that is telling us is that the degree on the top, when you expand it out, is smaller than the degree on the bottom. It's also telling us y cannot equal 0, by the way. There's a vertical asymptote at 2. Okay. So if there's a vertical asymptote at 2, that x minus 2 has to be a lone factor in the denominator. Are you with me on that? Okay. Now, the y-intercept is -2. We've checked these two boxes. These ones are kind of, I don't know what's going on there. Why do we need that? We're going to come back to it. You're told there's a point of discontinuity. Right? Not in the context box, but in the question, you're told there is, in fact, a point of discontinuity. Now, what does that mean? It means that since these are the only two non-permissible values of x, and 2 is where there's a vertical asymptote, 5 must be where there's a hole. And now we can check a couple of things. We can check, would this give a horizontal asymptote at 0? Yes, because the degree on the top, we just have a linear factor, so that's degree 1. The degree on the bottom, we have 2 linear factors, which makes it quadratic, that's degree 2. That's fine, we've got that now. Now the question becomes, and here's where things get a little sticky. Do we have a y-intercept of -2? You wouldn't be told that unless it's important. Right? You would not be told that unless it's important. So how do you find a y-intercept? And what we're really doing here is we're saying, is this correct? Because if it is, we can find the y-coordinate of the hole, which is what we're asked for. Right? Well, we're also asked for the x-coordinate of the hole. So how do we find out if that's true? We find out if that graph has a y-intercept of -2. And when I put 0 in for x, I get a y-intercept of 0 minus 5 over 0 minus 2 times 0 minus 5. Well, I get -5 on the top and 10 on the bottom. And I don't have to go much further to discover that that is not equal to -2. So the answer to this question is no, it's wrong. This is not the function. So how do we wrap our heads around this? The nice thing is this is the same idea we've covered already with polynomial functions, that there will be an infinite number of functions with a hole at 5 and a vertical asymptote at 2 and a horizontal asymptote at 0. I can take the entire function that I've created and say, it could be 2 times that whole thing, or -3 times that whole thing, or 100 times that whole thing. It will not change the fact that we still have these two non-permissible values. We still have a hole at 5. We still have a vertical asymptote at 2. And we still have a horizontal asymptote of 0. So what we have to do is find that value of a, that constant multiple, just like we did with polynomial functions. How are we going to do that? Let me just rewrite this. Well, if you want my advice, for what it's worth, I wouldn't worry about the x minus 5s, because whatever they are, they're going to cancel, right? So we're going to find a by using an ordered pair. It's a missing parameter. X is 0, y is -2. This is a monster of a question. Like, after we find a, we're still not done, right? So I put in the y-intercept, I put in the y-coordinate of -2, I put in 0 for x, and I end up with -2 equals a over -2. When I multiply both sides by -2, I get, finally, the function. Y equals a, which is 4, times the x minus 5 over the x minus 2, x minus 5. And just so I don't have to scroll back up, can you double check to make sure that that's the format of the question for the whole? So where's the whole? It's at 5, comma, put 5 in for x into whatever's left to find the y-coordinate of the whole. But boy, we had a long way to go just to get to there. So what are we going to have? Y will be equal to 5, nope, 4 over 5 minus 2, well, that's 4 over 3. So that's as I said, it's a monster of a question. It's testing almost everything about the horizontal and vertical asymptotes, the holes, the y-coordinates, and a concept of a missing parameter. So you're given two functions, f of x equals 6 to the x, and g of x equals the base 2 logarithm of x. And you're asking about 40. Okay. Number 39, by the way, is mixing together two compositions with a difference of functions. And if there's anybody who wants me to go over that, I will go over that in a minute. But I want to talk about number 40 just for a few minutes. There are two ways that you can approach this. First of all, you need to understand that when I say f of g of a is 75, and we write the following kind of schematic that we've been using, where you say, well, okay, I'm going to run something through one function and run it through the next function as well, that most times the thing that goes in at the very beginning, most times the thing that goes in at the very beginning is known to you. We don't know what's going in, right? What's going in is a, which we are asked to find. What comes out is 75. And f of g of a means f of g of a, which means a goes into g first, which is log base 2 of x. And then whatever comes out goes into f, which is 6 to the x, and whatever comes out of that happens to be 75. So this is how I would prefer to do it. It's how it makes the most sense to me and how I believe it makes the most sense to students. I do this in pieces. I say that there's some number that goes in for x here, and I get 75. And now what we realize very quickly is I'm asking you a Unit 5 question here. What is the value of x? Because we need to know that value of x so we know what comes out of log base 2 of x. Well, I take the log of both sides. And that means that when I bring that x down, this is the power law for logarithms. I get x log 6 equals log 75. So I now know the value of x. And I would highly recommend here, Marquin and everybody else, that you calculate that and you have it on your calculator. I wouldn't put log of 75 over log of 6 in here. Okay? I'd put a decimal, and I would carry all the decimals on my calculator. So what does that equal to? Log of 75, close the brackets, divided by log of 6, gives me about 2.41. Okay, and I have that. I can grab that anytime I want. But this number is 2.41. And that number is what comes out of log base 2 of x, which means that log base 2 of x is equal to that number. And again, we're back in kind of a Unit 5 question, although, you know, the hope is by now, certainly by the time you get to the diploma exam, this is not a thinker. When you look at log base 2 of x equals 2.41, you shouldn't put your pencil down and scratch your head and go, how can I find x? It should be ingrained in you that x will be 2 raised to that 2.41. And x, of course, is a, and that's what we need to do here. I need to take 2 raised to that answer, and I'm getting 5.3. Is that okay? Is there anybody who would like me to do 39, which is associated with this? Okay. Oh, I'm sorry. I said there's 2 ways to do this. And I'm going to show this to you because some of you might prefer to do it this way, but I don't. I think you're asking for trouble. But some of you might want to do it. You could say, well, f of g of a. Well, what is f of g of x? Well, f of g of x is 6 to the log base 2 of x. And you should know that. You should be able to write that. And then you could say, oh, that's equal to 75. It is true that if you solve this equation, you're going to get the same thing, because you have to take the log of both sides. That exponent will go down. But I think that's confusing, personally. Okay, let's take a look at number 39 now. So, you're told that there's 2 new functions that are not in the box. One of them is h of x, and one of them is k of x. And you need to know them because you're asked to determine h minus k of 2.4, which is h of 2.4 minus k of 2.4, right? Which means you need to put 2.4 into h, and you need to put 2.4 into k. And I would recommend determining h of x first. I mean, I shouldn't say that. I'm going to do it by determining h of x and k of x first, and then I'm going to show you another method. And that's just so I remember. So what is h of x? H of x is f of g of x, which means g of x goes in here. So f of g of x, which is h of x, is 6 raised to the log base 2 of x. What is k of x? Well, k of x is g of f of x. And I'm starting to realize that the second thing I'm going to show you, the second method, is probably the smarter one. But I'm going to do it this way anyway. That means that we are going to, for this one, put 6 to the x in here. So you get k of x equals log base 2 of 6 to the x. So now what we need to do is find out what h of 2.4 is, so that we can put that here. And we need to determine what k of 2.4 is, so we can put that here. And I think, you know, when we draw that diagram, that flowchart diagram, we probably could have just done that first and not worried about writing these functions this way. But because I've already started this, committed myself, we'll do it this way. And then I will quickly show you the other method, which I think is probably a wiser move. So I need to take 6 raised to the log base 2 of 2.4. I certainly wouldn't do this in one step on my calculator. I would figure out what log base 2 of 2.4 is first. And I'm using the change of base formula, okay? Because I don't have my calculator in that other mode, and I don't like that other mode. Now what I'm going to do is take 6 raised to that. So I just want to make sure that's right. 9.61-ish minus, and then I'm going to go over here. And this time I'm going to take 6 raised to the 2.4. And now I'm going to take the base 2 logarithm of that, which using the change of base formula is log of that over log of 2. And I get 6.2-ish. And I subtract them and get the answer, carrying all your decimals, you know, going up and grabbing that number on your calculator. I don't know why, after I talked about not building the equation for number 40, I decided to build the equation for this one. I think because 40 was more complicated and we were working backwards. I might have just done this for h of 2.4. I just would have gone 2.4 through log base 2 of x, and then run it through 6 to the x, and then done the same thing with the other one. Make sure I have that order right. Yep. Which I really hope that everybody sees that this is the exact same thing as this. You might want to just roll that around in your head for a second. That putting 2.4 into log base 2 of x and then the result into 6 to the x is the same as taking 6 to the log base 2 of 2.4. We have learned again and again and again that whenever you have a missing parameter, you find the missing parameter by loading in an ordered pair. I think you know that what's going to happen here is we have to load in 2 ordered pairs, one after the other, to get 2 equations. So I want to just put this in tabular form because it's what you're used to seeing. We have x here and y here. 6, 1, 8, negative 3. So when I load in 6 for x, I get 1 for y. I get 1 equals a over x minus 6 minus 1. Just a second here. 6 minus k minus 1. I was wondering where my parameter went to. There we go. My second equation is going to be negative 3 equals a over 8 minus k minus 1. So I'm putting in 8 for x. I'm getting negative 3 out for y. So I have to solve those two equations, and I would highly recommend just adding this 1 to both sides. You could multiply everything by by 6 minus k, but I think it's better to get rid of that constant first, or to collect your constants. If I add this 1 to the other side, I end up with negative 2 equals a over 8 minus k. Still good? Now I can, call it cross multiplication if you like. Call it multiplying by the denominator. I don't care. We end up with, for equation 1, 2 times 6 minus k is equal to a. And for, just trying to decide how to organize this. I guess it doesn't matter. For the second equation, I get negative 2 times 8 minus k equals a. And now I have to solve that system. Expanding out the first equation gives 12 minus 2k equals a. Expanding out the second one gives negative 16 plus 2k equals a. That's a pretty nice setup because we have negative 2k and positive 2k. So we add these, we get negative 4 equals 2a. Now I know what a is. It's negative 2. I just want to see what the format of this question is. Oh, it's the non-permissible value for x, which means it's k. So we're not done yet. I have to take, doesn't matter which equation. Put your value of a in that we got, which was negative 2, and then you can solve that. Is that okay? All right. So this is a marriage between an operation of functions, specifically a difference of f and g at a certain value of x, and a composition of functions, h of g, of a certain value of x. And what are we asked to determine? The value of f minus g of negative 3 plus h of g of 2. So, Paige, what we are asked to find here is this. F of negative 3 minus g of negative 3 plus that thing, right? So we have two basic operations going on here, the difference, and we're going to calculate each of these separately, and then this composition value, which I'm going to calculate elsewhere. So what is f of negative 3? F of negative 3 means go to negative 3 for x and read the output, which is 3. Minus g of negative 3 means go to negative 3 and read on g the output, which is negative 2. Now, what is h of g of 2? So I'm just double checking here. This means the 2 goes into g first, then the h, so I've got my kind of schematic drawn right. So 2 goes through g. Well, that means that I go to 2 and I read the output, and it's 3. So 3 comes out of G. 3 now goes into H. So I go to 3 and I read the output, and the output is -1, which means this is -1. So the 3 minus -2 is 5. 5 minus 1 is 4. Is that good? Okay. You know, there are certain things I can tell you without a doubt are going to be on the exam tomorrow. And this is one of them. You know, the y coordinate of the whole thing, number of ways that can be asked, that's definitely one of them. There are probably things that we've gone over today that you are not specifically going to be asked about tomorrow, but could be on the exam, the diploma exam. So the question becomes, how do we determine a, h, and k when we have a function of this form and we want to write it as y equals a over x minus h plus k? Well, you can recognize that h is always the non-permissible value of x. It is going to be where the vertical asymptote of the function is. And given that the original function in this form has over x minus 2, we know that h is 2. This is not the way I taught you to do this to begin with. I always think that students aren't ready, no offense, for this method at that point in the course. So we know that h, let me write a equals h equals k equals, and then I will show you the other way that I did teach you. And I did teach you this, it was just later on. H is 2. Okay. We know that k is where the horizontal asymptote lies. In other words, it's the non-permissible value of y, if you want to think that way. But we also know that we have a rule for finding the horizontal asymptote's location. It's if the degree on the top and the bottom are the same, you divide the coefficients. So that's 3 divided by 1. So we know k is 3. And what that gives us now, looking over here, is g of x equals a, which we don't know, over x minus 2 plus 3, which is k. So we have a missing parameter, which means we need to put in a number for x and a number for y that go together. Now how can where is that information? Because it doesn't say the graph passes through a particular point. But you have the equation. You have the equation of the function. You can generate a table of values as short or as long as you want. So you can pick a value for x that's allowed, and I'm going to pick 3. And the reason I'm picking 3 for x is because when I put 3 in the denominator will become 1, making my life easier. So when I put 3 in for x everywhere, I get 9 on the top minus 2, which is 7 over 1. And just in case I get cut off by the bell, you're going to find a by loading in that ordered pair and solving for a. The nice thing is when you do load in that ordered pair, that wise, crafty choice of choosing x equals 3 pays off again. Because now we're still over 1, so you're left with 7 equals a plus 3, which means a is equal to 4. If the bell rings, don't be offended. I won't be offended if you leave. But I will show you that you can do this with synthetic division. We're dividing 3x minus 2 by x minus 2. Multiply, you get 6. Add, you get 4, which means that this function is the same as 3 plus 4 over x minus 2. quotient plus the remainder over the divisor, and then you can see that A is 4, H is 2, and K is 3. We'll see you guys later.